Hello. So in this video, I'll be working through how to find the nth term of quadratic sequences. So a quadratic sequence is when the first difference isn't constant. The first difference is, well, let's work it out now. It's the difference between each of the terms. So that's plus 8, plus 14, and plus 12, and plus 16. So this is the first difference, which is not constant. It's not the same throughout. So therefore, what we do is we have to find the second difference. And to do that, we just treat these first difference as a sequence and then find the difference between each of the terms. So we have plus 4 and plus 4. So now we have a common second difference. Now it's a common second difference of 4. So this gives us a starting point for the coefficient of n squared. So what we do with the second difference is we divide it by 2 to find the coefficient of n squared. So that's 4 divided by 2, which is equal to 2n squared. So we have 2n squared. That's our starting point. But now, this original sequence has it's in the form 2n squared, as we worked out here, plus bn plus c, since it's a quadratic, which means that we need to work out what b and c are. So we need to work out what bn plus c is so that we can find the nth term of the entire sequence. So what we do is we make a table. So firstly we have our 2n squared plus bn plus c, which is just the original sequence. So that's 2, 10, 22, and 38. And then we have 2n squared, which is, so now we need to complete the table for the first 4 terms of 2n squared. So that would be 2 times 1 squared, 2 and 2 by 2 squared, 2 by 3 squared, and 2 by 4 squared. So 2 by 1 squared is just 2, 2 by 2 squared is 8, and 2 times 3 squared is 18, and 2 times 4 squared is 32. So now we have the first 4 terms of the sequence 2n squared. So now what we do is we take the 2n squared and we subtract it from the original 2n squared plus bn plus c. And when you subtract it, the 2n squares cancel out. They cancel out. They become 0. So all you're left with is just bn plus c when you subtract. So now we also need to subtract each of these terms. So what we do is, firstly we do 2 minus 2, which is just 0. And then we have 10 minus 8, which is 2. And then 22 minus 18, which is 4. And 38 minus 32, which is 6. So now we've subtracted 2n squared from 2n squared plus bn plus c to obtain bn plus c as a new sequence, 0, 2, 4, 6. It's a subsequence. So now we need to find out the nth term. This is a linear sequence, which means that the first difference is it's common. We can see that the first difference is just 2 plus 2 for all of them, all the terms. So now we know that the b is 2. So we have 2n plus c now, because in a linear sequence, whatever the first difference is, that is the coefficient of n. So that's why we have 2n here. So now we have 2n plus c. So how do we work out what c is? So we take down our bn plus c sequence, And now to find out what c is equal to the 0th term. So what that means is that, so firstly, this is the first term of the sequence, right? And then this is our second term, third term, fourth term, and so on. So to find c, it's the 0th term. 0th. So it's the term that comes before the first. So if we're adding 2 to increase in for example, to go from the first to the second term, we have to add 2. But that means that to go from the first to the 0th term, we have to subtract 2. So that gives the 0th term as -2. This is the 0th term, -2. So therefore, our c here is -2. So now we have a 2n minus 2. That's the nth term of this sequence right here, 0, 2, 4, 6, 2n minus 2. So now we have that, and we have the initial coefficient of n squared, which is 2. So we can combine them to give, so we can add the 2n squared here from up here that we obtained. And now, therefore, our final sequence is 2n squared plus 2n minus 2. That is the final sequence. You can also substitute in values to make sure that that works. So for example, let's substitute in n equals to 3, which is the third term of the sequence. So the answer should be 22, since that's the third term of the sequence. And if you substitute in and n equals to 3, you get 2 times 3 squared plus 2 by 3 minus 2, which if you calculate it is indeed equal to 22. And you should also check it for a few more terms in the exam, just to ensure that it does work for all of them. And you'll see that this 2n squared plus 2n minus 2 does indeed give us the nth term for this sequence. So now I have a question for you, that is to find the nth term of this quadratic sequence, 3, 8, 19, and 36. So solve this question and let me know in the comments what you guys are answer. Thank you very much for watching this video. I hope it was helpful.